So I'm going to talk about the Gauss-Jordan method again. You've already had one video that sort of intros you to that. We're going to use augmented matrices, but I wanted to do this in terms of a word problem. So let's get the relevant parts of our word problem. I'll highlight it up first. I went on a 14-day U.S. tour. I was in Boston, SoCal, Chicago, and Indiana, so let's use B, S, C, and I. My Boston costs were $240. My SoCal costs were $400 a night. In Chicago, I spent $160 each night. And in Indiana, I spent $200 for a total cost of $40.40. Then we have some information. The days I spent in SoCal was the same as the number of days in Boston and Indiana. Total days in Boston and Indiana. And also, I spent 3 times as many days in SoCal as I did in Chicago. This wasn't quite the correct number of days, but I was actually this summer in all 3 or 4, can't count, of these locations. Costs per day include hotel, lodging, food, plane ticket, ratioed out, all that good sort of stuff. The $40.40 cost might be a smidge high, but I was gone for about a month, so anyway. I messed around with the days so that we could get a real time going on here. So, let's look at this. First, we need to create equations. I know that I've got these 3 letters. I really, really want that to be 3, don't I? I've got these 4 letters. And these 4 letters are what I'm dealing with. Since I have 4 letters, I know I need 4 equations. I could give these letters sort of a more grown-up mathematical name. X sub 1, X sub 2, X sub 3, X sub 4. I'm going to stick with the BSCI just for now. But I just want to point out that all these equations that I'm doing, I could have done like this. We did the addition method before for solving some word problem stuff. We don't want to do the addition method anymore. I'm going to have 4 equations because I have 4 unknowns. So let's talk. I'm curious about how many days I spent in each city. So each of these things is a number of days. First, be very clear what your variables are. Before you start creating equations, you need to know what you're talking about. So here's the equations. Boston days plus SoCal days plus Chicago days plus days spent in Indiana equals 14. And right there's my first equation. Next, I have information on costs. Each day in Boston, I spent $240. Each day in Southern California, I spent $400. Each day in Chicago, I spent $160. And each day in Indiana, I spent $200. And my total trip cost was $4,040. I still need some more equations, and that's what this last part gives me. First of all, it tells me, and I'm going to do this sort of scratch work over here, it tells me that the days I spent in SoCal were the same as the days spent in Boston and Indiana. I want to have these all in the correct format where everything's lined up nicely in little columns. So I subtract off B and I, and I make sure I keep it in the right order. So I have minus B plus S minus I equals 0. If I wanted to, I could do plus 0 Chicago, but I don't have to. That's not required. My last piece of information, I spent 3 times as many days in SoCal as I did in Chicago. Now, the temptation at this point would probably be to do something like this. Don't. That's not true. We spent 3 times as many days in SoCal as we did in Chicago. So the actual equation is that SoCal days equals 3 times Chicago days, which means when I translate it out and with the subtraction, I've got S, and I'm going to then subtract off the 3C, and this will equal 0. So I've got S minus 3C equals 0. Alright, so now I have this equation. I've moved it over here. I don't know, this was my last equation. Let's move it down 1. I've got this equation. Let's put it over here. Minus B plus S minus I equals 0. I now have 4 equations, and so I can fit this into an augmented matrix. And my augmented matrix looks like this. I have 1, 1, 1, 1. In the augmented part I have a 14. I've got 240, 400, 160, 200, 40, 40, minus 1, 1, 0, minus 1 and 0, and 0, 1, minus 3, 0, 0. This is my augmented matrix now. So now I'm going to take this and I'm going to do row operations on it. Remember our row operations. I can swap rows around, I can add and subtract rows together, and I can multiply a single row by a number as long as that number is not 0, because that would zero out that row and wouldn't do much good for me. I also have my general recommended process where I try to go top to bottom, left to right, getting that 1, 1, 1, 1 pattern down the diagonal. This is already a 1. If I circle this 1 stuff, I'm going to say that I'm going to pivot around this 1. That means I need to get all of these guys here to become zeros. This guy's already a 0, so he's done. So let's talk about my first set of row operations. I'm going to write the row that I change first, the row that I'm changing by second. So row 2, I need to subtract 240 times row 1, because I need to take 240 minus something times this, and it needs to equal 0. So whatever this number is, minus the row 1 thing. I'm going to double up my operations because I don't want to write 50,000 matrices out. So I'm also going to tackle row 3. Row 3, I'm going to just add row 1 to it, because negative 1 plus 1 will give me the 0 I'm after. Alright. Notice here that I don't need to change row 4, so I'm going to copy row 4 just as it was. And also I'm not changing row 1. Row 1 is doing the changing here. So I'm going to copy him down just as he was. Now let's tackle these 2 rows that I change. Alright, so now I have 240 minus 1 is going to give minus 1 times 240, dealing with this top equation here. This minus this gives me 0. I've got 400 minus 240 gives me 160. I've got 160 minus 240 gives me negative 80. And I've got 200 minus 240 gives me negative 40. And finally 40 minus 240 times 14 gives me 680. See what I was doing here? I take this number, I plug it into this spot in row 2. Then I take this 14 and I plug it in here and do 240 times 14. Then do that subtraction. Once you've got this pattern over here, which let me erase some things so it looks a little lot more like a pattern, you know exactly what to do. You know what has to happen to this first term to make this a 0, and then you just continue following the pattern on through. Some people tell me, oh, I have trouble figuring out these equations. That's because you're looking at too many things. When you're trying to figure out that equation, all you're doing is looking at these 2 numbers. How do I subtract this number off of this one to get this 0? So it's always going to be this row, which is row 2, plus or minus something times row 1. So now you just have to figure out, well, 240 minus what equals 0? Well, 240 minus 240 equals 0. So that tells me exactly what the numbers are. All right, let's add row 3 and row 1. Row 3 is negative 1. Row 1 is 1, so that gives me 0. 1 plus 1 gives me 2. 0 plus 1 gives me 1. Minus 1 plus 1 gives me 0. And 0 plus 14 leaves me with 14. Alrighty. I'm going to again do 2 steps. I'm going to be kind of careful. The first thing I'm going to do is I'm going to take row 2 and I'm going to divide it by 40. We say I multiply by the fraction 1/40th. That's going to bring these numbers kind of down to size. After I do that, in the same step, I'm going to switch row 2 and row 4. I'm going to do a row swap. I'm going to do that because the next thing I want is I want the number 1 right where this 160 is right now. So I'm going to get that 1 there just by taking this 1 down here and moving it up there. I'm going to do that row swap. So watch carefully what happens. 1, 1, 1, 1, and 14. That's not changing. I'm also not changing the third row, 0, 2, 1, 0, and 14. Nothing's changed so far. I'm swapping rows 2 and row 4, so let's move this row 4 up to row 2 spot, 0, 1, minus 3, 0, 0. And now I'm moving row 2 down here to the row 4 spot, but I'm also multiplying through by 1/40th. So I get 0, 160 divided by 40 gives me 4, negative 80 divided by 40 gives me negative 2, negative 40 divided by 40 leaves me with negative 1, and 680 divided by 40 leaves me with 17. All I've done by dividing through by that number is made sure that this bottom row here now looks a little nicer. It doesn't have such huge numbers. All right. Notice something. My first column is exactly like I want it. In my second column, I have this number 1 here, which I like, but I have to change each of these numbers using that 1. So it's time to do some more row operations with additions and subtractions. Row 1, I need to subtract row 2, because 1 minus 1 will give me 0. For row 3, I need to subtract 2 times row 2. And for row 4, I need to subtract 4 times row 2, because this is a 2 and this is a 4 here. So now I'll carry through those operations. I'm not changing row 2, so first thing I do is copy down row 2 exactly as it was so I don't accidentally change it. Alright. 1 minus 0 gives me 1. 1 minus 1 gives me 0. 1 minus 3, minus a negative 3. Notice the minus here. A 1 minus a negative 3 gives me 4. 1 minus 0 gives me 1. And 14 minus 0 gives me 14. So I have 1, 0, 4, 1, 14 on top. As I'm doing this, I'm doing it rather quickly because, well, it's on a video so I can. You should slow down, hit pauses if you need to, make sure you actually calculate it out and convince yourself that you know exactly why I've written every number I've done. With video editing, I was able to make sure that I went through this whole process making no mistakes. So each number I write, I believe, is perfect. You should know why I've written it down. If you don't, work it out. If you're still working it out and you're still having trouble, it's a great time to shoot me an email. Alright, let's tackle the third row. 0 minus 2 row 2 is going to give me 0. 2 minus 2 row 2 is going to give me 0. 1 minus 2 times negative 3 is going to give me 1 plus 6, which is 7. 0 minus 2 times 0 is 0. And 14 minus 0 is still just 14. Finally, for row 4, 0 minus 0 is going to give me 0. 4 minus 4 gives me 0. Negative 2 minus 4 times negative 3 is negative 2 plus 12, which is positive 10. Negative 1 minus 0 is 1, negative 1. And 17 minus 4 times 0 is just 17. So I've got 0, 0, 10, minus 1, and 17 for my bottom row. Okay, I've got my first 2 columns good. Again, we have this idea of top to bottom, left to right. This lets us not have to double up on any of our work. There's plenty of ways you could solve this matrix. This one I'm doing is only one out of at least 3 or 4 that I can think of doing right now off the top of my head. I bet there's probably more like 10, 20, or maybe even 100 different ways of solving this. If you solve it correctly, doing the correct row ops, it doesn't matter what order you're doing things in. You might have fractions show up in yours. I avoided fractions in mine because I don't like fractions. And if you did it correctly, you and I should all get the same answer at the end. If you don't get the same answer as me, then you did an addition mistake somewhere or you've done a row operation incorrectly. Next, I want to pivot around this number 7. I can easily change 7 to the number 1 by doing 1/7 times row 3. So let's make that switch first. Top row doesn't change. The second row doesn't change. It's the third row that changes. And finally, the bottom row at this point is not changing. Okay, so I've got my numbers down again. Now I'm pivoting around this number here in the third row, so let's talk. Row 1, I need to subtract 4 times row 3 from, because there's a 4 here. Row 2, I need to add 3 times row 3. And row 4, I need to subtract 10 times row 3 to get the zeros there. Row 3 is the one that's being changed, or rather, excuse me, row 3 is the one that's not being changed. It's the one that's doing the changing. So I copy him down. Everyone else is going to change. 1 minus 0 leaves me with a 1. 0 minus 0 leaves me with a 0. Negative 1 plus 1 leaves me with a 0. 1 plus 0 leaves me with a 1. And 14 minus 8 leaves me with 6. Done with that. Row 2. 0 minus 0 gives me 0. 1 minus 0 gives me 1. Negative 3 plus 3 gives me 0. 0 plus 3 times 0 gives me 0. And 0 plus 3 times 2 leaves me with 6. And finally, for row 4, 0 plus 0 gives me 0. 0 plus 0 gives me 0. 10 minus 10 gives me 0. Negative 1 minus 10 times 0 leaves me with negative 1. And 17 minus 20 leaves me with negative 3. Alright, on the bottom row, I multiply row 4 times negative 1. This makes these positive. And now the last thing I need to pivot around is this guy, and the only thing that needs to be changed is row 1. So I'm going to do row 1 plus row 4. Excuse me, minus row 4. I've changed those to positives. This row doesn't change. Row 2 doesn't change. Row 3 doesn't change. Row 4 doesn't change. But when I add these rows together, row 1 minus row 4, 1 minus 0 is 1, 0 minus 0 is 0, 0 minus 0 is 0, 1 minus 1 is 0, and 6 minus 3 leaves me with 3. The order of my equations from way up here was Boston, SoCal, Chicago, and Indiana. Boston, SoCal, Chicago, and Indiana. What this means is I spent 3 days in Boston. I spent 6 days in SoCal. I spent 2 days in Chicago. And I spent 3 days in Indiana. If I were to add these all up together, they add up to 14, which is a good check because I spent 14 days total. And if I multiplied each of these by the different monies that I spent per night, I would find out that it did add up to 40/40. That's a way you could check your work if you thought you might have done something incorrectly. Alright, so this is the Gauss-Jordan operations. I've done it in the context of a word problem. Some of the problems you have will start out with you already having these equations, and so you can jump right into the augmented matrix. But this is how row ops work. In particular, if some of this stuff over here was giving you trouble, you should give me an email because we need to get this working for you.